Okay, so today we're going to be going over a dead MacBook Air motherboard. So when I plug the charger in, it doesn't turn on. I don't have a fan plugged into it, so you can't see it not turning on, but you can just trust me that it don't work. So if I drag the oscilloscope over a little bit, you'll be able to see that where I want to have a 5-volt rail, that I have a no-volt rail. See? I got nothing. Take it away, put it there, take it away, put it there. You may wonder how I know to measure there. Well, as I said, the schematic will actually give you a list of power rails in the machine. And one of the things I complained about in a prior video is how on the older boards, they would give you that list of power rails very, very quickly on page 1 or 2. On the newer boards, they give you that list of power rails on page 62. Because it's nothing like putting the thing that you need to know first on page 62 of the schematic. But that's Apple. So if we go through, I have PP Budget G3 hot. I measured that. I have PP DCN. Obviously, if I have PP Budget G3 hot, which is a power rail on the machine, the DCN is working because this didn't work, I wouldn't have anything. PP3V42 is present. I know PP3V42 is present because I have an orange and a green light on my charger. As I've explained in previous videos, you need the one-wire circuit working to have a light on the charger, and the one-wire circuit is powered off of PP3V42_G3 hot. I've covered that in many other videos, so if that's confusing, you could simply search my channel. You can use the search feature on the channel, search for one-wire, and you'll find that. I have PP5VS5, that's great, but then I'm missing PP5V_S4RS3. So let's look at how that power supply works. I'm sick and tired of being sick and tired. All right. All right, so that's made by U7501, right? Now, before I go checking anything in this chip and seeing that anything works, the first thing I want to do is, remember when I explained in the integrated circuits video that one of the things that you should look for before you troubleshoot all the resistors and the capacitors and all that nonsense in a circuit is that you should see that it's actually being told to turn on. So a lot of these chips simply have enable pads like CEN1 and EN, enable. So where am I going to find that? So I'm going to look on my... So I'm going to look on my board view. So on my board, I'm going to N, I'm going to type that, and it's going to show me everywhere on the board that shows up. And when I go to look for it, again, I'm actually skipping past a lot of stuff here. I'm not looking to see if any of those resistors are bad. I'm not looking to see if anything in between is bad. I want to go to the top of the chain and see if that even exists. And when I look, my multimeter says that I have 0 volts. So that's supposed to be 3 volts. So PM_sleep_S4_L. That comes from the PCH, which is integrated into the CPU in this model. So see here that says System Power Management, U0500. So if I go to this and I put U0500, I see that is the CPU. Now, the reason the CPU on the Haswell models is a little bit bigger than it was on the Ivy Bridge models, if you noticed on the Air, is because these don't have a PCH. So you used to have a your CPU used to have a North Bridge and a South Bridge. Then Intel moved over to having a CPU and having an MCP. It integrated all the functions of the North Bridge, South Bridge, graphics chip into one thing. Then you had a CPU and a PCH. So instead of calling it an MCP, now they call it a PCH. Since there was no longer a discrete graphics chip inside of the MCP, the graphics was in the CPU, they started calling the other thing that does all the managing of the USB and the screen and all that good stuff a PCH. Now the PCH is actually integrated into the CPU. So this is a signal that used to come from the MCP or the PCH. Now it's coming from the CPU. So see all these different sleep signals? They're there to get the computer in different states. So, to get it into an S5 state, an S4 state, an S3 state, an SO state, all of this is coming from here. And it's not there. So this is going to cause me to look at one of two things. So the PCH is not sending a signal that I need to start an S4 power rail. So is it my PCH or is it the BIOS? So let's look over here, and we're going to take a look and try to get an idea of what's going on. So I look over here. Let's see if what my CPU looks like. So my CPU looks pretty. I'm not really complaining about anything here. CPU looks... Is this... This is upside down, ain't it? Mother. Okay, better. I can't really say I'm complaining about how any of this looks. But then now let's see what the BIOS chip looks like. So let me just show you a BIOS chip on the schematic here. So this is the SPI ROM. It's the EFI chip. On PCs they call it a BIOS chip. And this has a lot of important information. And you'll see that where it communicates with other parts of the machine. Over here, this is listed under PCH net properties. All of this gets listed under PCH net properties. So you can see that the lines on this BIOS chip are communicating with the PCH. Now, if I look at the BIOS chip, that doesn't look very nice. Remember when I talk about those red probe points, looking for those red probe points? So let's set my multimeter to a mode where it's going to excuse me, where it's going to beep every time there's continuity. The noise reduction thing that I got going on is actually so good that you probably won't be able to hear the beeping of the multimeter. All right, so from here to this, obviously, there's nothing going on there. Let's see. So we got nothing. Surprisingly, that beeps. That does not beep at all. Let me just get... So from there to there. So those traces are corroded in junk. Now I'm going to check and see that those resistors are actually still decent. So let's look up their values. I'm going to look up their values here. Hey, 6101, 6123, 6114, 6117. Why put them in order, Apple? Why put them in order? Let's see. All right, so 6102. Let's put back in the regular resistance mode. The 6101 is supposed to be 3.3K. That's fine. Next one, 6123. I just hit V to make that happen, by the way. Verbose mode. It shows everything in there. All right. 6123. R6123. That's supposed to be 24.9 ohms. It's fine. 6114. It's supposed to be 24.9. And the bottom one is supposed to be 15. So we got 24.9. Let's see what we got there. Good enough. And good enough. So now the job is going to be... come on, stay put, you piece of shit. All right. Now it's going to be recreating those traces. Now there's also a really damn good chance that the BIOS chip itself is messed up. But we're not going to know until we get past this point. So we're going to scrape away some of the stuff on the board, like so. Go side to side, side to side, side to side, side to side. We're going to do that here. We're going to run little, tiny little wires. And I'm going to scream and curse every step of the way because I hate this shit. This one's actually still good. I'm going to see if this beeps through after I just... Let's just scratch away and see if soldering will actually fix this. Yeah, so here there's nothing left. There's no point in etching away any further there. Got my alcohol dispenser that never works back. It only works when you smash it, and at that point the alcohol goes into your eye. The air filter on. Don't feel like killing myself. Some people have said, you know, you don't get cancer from that. You only get emphysema or you only get this other. I don't want any of those things. I mean, oh, what is like? Is that supposed to pacify me? Oh, you're not going to get, you're not going to get cancer. You're only going to get emphysema. Get the fuck out of here. I don't plan on getting any of those things. That's awful. Absolutely awful. On to the next one. Plenty of time for cleaning once this is all done. I hate running wires that you can barely see. I gotta clean the little fibers away. There. I should have just got the brush instead of using a Q-tip. At the end, there'll be time to properly ultrasonic and brush this off. But that's if it works. By all means, if it works, then I will spend time on that. Nice try. I get it. You want to touch something that's totally unrelated to what I'm trying to solder you to. And that's cool, wire. I know that your job is to make my life miserable. To try to fuck up my attempts to make money. That's part of the game. That you're gonna lose. You are gonna fucking lose. I get that that's part of the game. Okay. All right. So if I measure for 5 volts where there was no 5 volts before, as you can see, it just jumped to 5. So when I take it away, 0, 5, 0, 5. And also, one of the most important things in the world is happening here, which is that the fan is spinning. So here the problem was we had a missing sleep signal after what was most likely water damage. I honestly don't remember. I'm fairly certain this one was liquid damage. And the sleep signal was missing. The sleep signal is what tells it, okay, enter an S5 state, enter an S4 state, enter an S3 state. It's what sets the power states of the machine. We didn't have any of the S4 voltages coming on. Without the S4 voltages coming on, you're not going to see the S3s and the SOs coming on. So I honestly don't remember off the top of my head what S4 is. I know S5 is off, or I think S4 is hibernate, S3 is suspend, and SO is on. I'm not an expert on it. I just know that I want to get to SO. And I was going down my list of power rails, and I noticed that an S4 power rail was missing, and that chipset on the board looked totally fine. One of the S4 power rails was missing, so I showed you how we looked through that list of power rails on page 62, because MacBook Airs decided to put it on page 62 instead of page 2 or 3, like any normal documentation person would, and the power rail was missing. So that power rail was ultimately enabled by that sleep signal. That sleep signal comes from the PCH, which is integrated into the CPU, and that was missing. That's integrated with the BIOS. When we look at the BIOS chip, or the SPI ROM chip, to put it more properly, since MacBooks don't have a BIOS, they have an SPI ROM, it was corroded. The little traces were corroded going between the BIOS chip and the resistors. And when we replaced that, I didn't even check to see if we had a sleep signal anymore. Because I know we do, because we have 5 volts where there's supposed to be 5 volts, and the fan spins and turns on. So again, there's going to be a lot of people who do silly things. And this is one of the things about BGA rework that really gets me, is that people think that the machine fixes the boards. They think that if you just get the machine, you're set. And like, they would totally replace an MCP. They would totally replace a PCH or a CPU, because they look on the schematic and it says on the schematic that the PCH creates the sleep signal. The PCH is not working. Let's replace the chip. The chip is fine. It's the traces that are bad. And that's one of the things I want to get across, is if you have your brain, you don't have to spend money on tools, because most of the time you don't need them. You just need your brain. That's $325 plus tax. Okay, so as I said, you can always clean the mess up later, and I've been getting some comments recently where people go, that's bullshit, it doesn't work, you need to clean it immediately. And no, I really don't. Here's the thing, and if I spend time cleaning that, I'm going to break my 20-minute rule, which is to not spend more than 20 minutes on a board. And that's something that I take seriously, not to waste time on. So, if you look here in the microscope camera, you'll see that it comes out pretty neat. I mean, again, this is after, obviously you can see there's some dirt on the lens. So like over there, you can see that's junk in the trinocular port of the microscope, because it doesn't come with, you spend like $1,000 on the setup and you don't get sent something that will close the top port, so you don't get dust in it when you're moving it back and forth. But needless to say, that is complaint for another video. So that this, and besides that little piece of dust over there, whatever this thing is that decided to stick around. What are you, a piece of sawdust, wood? Get out of there. Shoo. Get up. You can see that it's, for the most part, it's pretty neat. I'm not going to say it's the prettiest thing in the world by any means, but it works. And that's that. So what I'm going to do here is put it back together so that you can see that it actually works. You know, again, you got to see the fan spin, and the fan spinning is pretty damn cool. And you got to see that it didn't work and that it did work, and you got to see what I did to get there. But ultimately, at the end of the day, I want to show you that the work that gets done actually works. Because again, this is very important. If I'm showing you how to do things, and I'm telling you this is what you should do, this is why you should do it this way, and then I show it to you not working, like, why would you listen to me? What is the point? You know, what is... I feel like for this channel to be at all relevant, and for any piece of information to really be relevant, that you should be able to demonstrate that it's actually correct. Okay, it was pretty clean after all the work I did, but I still wanted to get rid of any sort of gunk that would get in between the new thermal paste. So we got some new thermal paste here. This is the boring part of the reassembly. You know, I haven't been here for the past few weekends. I had to hire somebody to work since I had something else I had to do. And one of the things I noticed when I came back, so on the weekends, there's none of the other people here that, that fix things except really, really basic stuff, except me. So I had to do all the regular jobs. And what I noticed is just how I've really gotten over any of this. Like, I used to, and I feel really bad saying this out loud, but I used to get excited even at the really, really mundane stuff, because it was money in the bank. Like, every time I did something and it worked, I was profiting off of it, and that was pretty cool. And then now it's not about greed. It's just about a lack of desire to do things where there's no brain work involved. I mean, it sounds greedy, but there's really not. You can't pay me enough money to do the same thing over and over again. It's just, I will lose my mind, and I just can't. So, when I was sitting here doing the same thing over and over and over, and reassembling the same thing, I had to do 6 or 7 MacBook Air screens in a row. I damn near wanted to shoot myself. I mean, really, it was incredibly, incredibly boring. And you know where you're starting, you know what the middle is going to be like, you know your ending, you know exactly what you're doing every step of the way. There's no adventure, there's no fun, there's no detective work, there's no figuring anything out. It's replace keyboard. Okay, I know exactly which 150 screws I'm going to have to take out. I know exactly how much it's going to suck as I'm unscrewing each one of them. And it's just boring. I just have no patience for mundane work anymore. Seriously, jackass? Oh, you fucked up the fan connector. I'll have to take a look at that later. A lot of people say that wholesale clients are better because you have to deal with less bullshit, but you really don't. I mean, wholesale clients are often actually worse than the end consumers. In terms of just breaking shit that you're not supposed to break and arguing. I mean, yeah, the whole unplugging cables and plugging them back in, and when again it's the exact same thing every time, is just boring. So boring. Okay, so I've put it back together. Not completely, it's still, not all screwed in, but as you can see, I can turn it on. It does chime, and it is going to boot into a working operating system, which means that the work that we did worked. It's not doing any of that nonsense where it runs really slow. And yeah, we're pretty much set. So this is a working board repair. And again, Don't jump into the idea of replacing an MCP, replacing a PCH, replacing a ball grid array chipset, when in reality your problem is a circuit problem. 99.9999999% of the problems you're going to encounter are circuit problems requiring circuit rework and trace rework and running little jumpers and replacing resistors and small ICs. They're not replacing big chips. So a lot of the time when you think that the big chip is at fault, just look a little bit closer and you're going to see. Again, if you use your brain, you're going to see it's probably something else.